Hi everyone, for this question, P, Q, and R are 3 points with coordinates 1 to 2, 2, 1, 2, and 2 to 1, respectively, and O is the origin. For the first question A, find the position vectors for P, Q, R. Position vectors means from origin to the coordinate respectively. So position vector for PQR is referred to OP, OQ, and OR. So OP and OQ and OR can be referred to its coordinate. So change the coordinate to vector, which is 1i plus 2j plus 2k. For coordinate Q, 2i plus j plus 2k. For coordinate R, 2i plus 2j plus k. Then for question B, express the equation of the line QR. So we're having a line from Q to R in the vector form R equals to U plus lambda V, where lambda is a constant. So in finding a line equation, we need what is our position vector in the line, and then we need the direction vector that represent for the line. So for position vector, it will be represented by U. For direction vector, it will be represented by V. So this line pass through Q and R means our position vector that we can use here, U, we can choose either position vector for Q or position vector for R, which is 2, 1, 2 in vector form, or 2, 2, 1. Meanwhile, for finding the direction vector V here, it will be the direction for this vector. So this vector, this line having the direction from Q to R, so that the direction vector will be forming from the point Q to R. So to find vector QR, we need QO plus OR. So QO and OQ, you can see we're having an opposite direction, means this is negative vector 2, 1, 2. And then OR, we already find it, which is 2, 2, 1. Simplify this, it gives us 0. And then negative 1 plus 2 is 1. And then negative 2 plus 1, negative 1. Means that direction vector is 1j minus 1k. Then we can put in our equations here. Where R is our general form equals to point, either we can choose 2, 1, 2 or 1 or 2, 2, 1. So I choose 2, 1, 2. Plus lambda V. V is 0, 1, negative 1. So I write this vector in vector form, or we can write it in full, which is 2i plus j plus 2k, then lambda times with j minus k. Then for part C, find the equation of the plane. Pass through the point P and perpendicular to OP in the form of R dot n equals to L. So when you want to find equation of the plane, formula will be R dot n equals to A dot n. What do we need here is finding out our normal and finding out a point, so that this is the position vector. So they want the equation of the plane in vector form, where you can see r dot n equals to L. Then, from our understanding here, our plane given is passed through the point P. So inside here has a point P, and it is perpendicular, means it having 90 degree with the vector OP. So the vector OP, let's say this is O, vector OP. So in plane equation, what we need is we need to find out what is our normal. Normal is a vector that always perpendicular to the plane. So from here we can know that OP is perpendicular to the plane. Therefore, OP will be our normal, which is 1 to 2. And then we need to find out what is our point that the plane passing through. The point passing through the point P. So the point P here will be the position vector 1 to 2. Then we put into the equation where r dot n equals to a dot n. So remain it in vector form. So for the right hand side here, we simplify 1 dot with 1, we get 1. 2 dot with 2 will be 4. So lastly, r dot n equals to L, which is 9. So this is our equation of the plane in vector form.